Soalan 1. Describe why we need to have a measure of variance even though we can easily get measure of center from data set. First, important as a mean to visualize and understand the data being considered. Second, measure of how dispersed or spread out the set. Something the average, mean or median is not designed. Okay. Untuk nombor 2, dia suruh cari mean, median dengan mode. So untuk mean, kita tambah hasil semua data bahagi dengan bilangan data. So jawapan dia 2.35. Untuk median pula, kita akan susun dia mengikut dari nombor yang kecil hingga nombor yang besar. Lepas tu kita akan ambil data nombor 10 dan 11 sebab dia di tengah-tengah. So jawapan dia 2 tambah 2 bahagi dengan 2. So jawapan dia 2. Untuk mode pula, untuk kekerapan yang paling banyak. So untuk kekerapan yang paling banyak adalah 1 dan 2 sebab bilangan 1 dan 2 adalah 5. Last sekali, soalan dia, which measure of center do you think is the best here? Explain your answer. So the best measure of center is mean because the most common measure to find average data. And most people think of when they hear the word average.
Now I'm going to explain to you about question 3. Question 3.1. So let's go to the list of data. So based this question, we need to determine the quartile, the 3 quartile, which is quartile 1, quartile 2 and quartile 3. So to obtain this quartile, we need to use the formula from the notes like this. Then we go through to the question 3.2, which is we need to obtain interquartile range. The formula is quartile 3 minus with quartile 1, we will get the interquartile range. Then we go through to the question 3.3, which is we need to search and obtain the 5 number summary. The 5 number summary is lowest value of the data, quartile 1, median, quartile 3 and the highest number of data, like this. Okay, that's all from me. Thank you.
Now I will talk about question 3.4, which is outlier. First, outlier is the smallest number, Q1 minus 1.5 or Q3 plus 1.5. So for the Q1, we must minus 1.5 equal to 48 minus 1.5 in bracket 20.5 equal to 70.25. So the Q1 is 70.25. For the Q3, we must add 1.5. So 68.5 plus 1.5 in bracket 20.5 equal to 99.25. So there is no data value within range 70.25 and 99.25. So there is no outlier for this data. We must conduct a box plot. So we can refer to 3.3 to conduct the box plot.
Okay, now we'll move on to the question 4. I will explain the formula about sample mean, sample variance and sample standard deviation first. For sample mean, you can see the formula and I will explain about it. The term X bar represent the sample mean, and the symbol summation X used in this formula represent the sum of all score. Net sample variance, the symbol S square represent the sample variance. Net sample standard deviation, where the term represent the sum of the square deviation of the score from the sample mean. Now we'll move on to the population mean, population variance and population standard deviation. First, population mean. The formula is and the symbol represent the population mean, where the symbol summation X represent the sum of all score present in the population. Same as sample mean. Now population variance. The symbol where the same as sample variance is represent the population variance. And finally, population standard deviation, the symbol, and the terms SQRT used in this statistical formula denote square root, where the term summation x1 minus u square used in the statistical formula represent the sum of the square deviation of the score from their population mean. Thank you.
For the number 51, we need to compute the population mean enrollment of the UC campuses and round your answers to 2 decimal places. So the formula of mean is mean equal to summation of x divided by n. So after we sum the x, we will get n divided by 8, we will get 17.2875. So the answer will be round to 2 decimal places and it will be 17.29 thousand students. For the 52, we need to compute the sigma, or known as the standard deviation. So the formula of standard deviation is sigma equal to square root of summation of x minus sigma power of 2 divided by n. So the total will be square root of 41.7786, and after we square root the answer, we will get 6.46. For the question 3 of number 5, we need to letting x denote enrollment, specify the standardized variable which is z corresponding to x. The answer of the question number 3 will be z equal to x minus mean divided by the standard deviation, and it will be x minus 17.29 divided by 6.46.
For number 5, for Roman, the question is, without performing any calculation, give the mean and standard deviation of z, and then explain your answers. So, the answer for number 4 is mean equal to 0 and standard deviation equal to 1. This is because as the sample size n increase, the distribution of the standardized sample means of any random variable always approach the same fixed probability distribution function. For number 5, Roman, construct a box plots for data in table 4 and then interpret your graphs. Number 5, we need to do a box plot. For box plot, we need 5 things, which is highest value, lowest value, quartile 1, median, and quartile 3. So from the data, the highest value was 24.9 and the lowest value was 2.9. For quartile 1, we need to arrange the data first, and then 1/4 multiplied by 8 and we will get 2. So from the data, get the second data. So the answer will be 13.7. For the median, 1/2 multiplied by 8, so we will get the fourth data. So the answer will be 18.1. For quartile 3, 3/4 multiplied by 8, we will get the sixth data. So the answer will be 20.3. To interpret the box plot, we need to find outlier. But before that, we need to find interquartile first. To find interquartile, Q3 minus Q1, which is 20.3 minus 13.7. The answer will be 6.6. So, the outlier is quartile 1 minus by 1.5 multiplied by interquartile. So, it will be 13.7 minus 1.5 multiplied by 6.6. So, the answer is 3.8. Another outlier is quartile 3 plus 1.5 multiplied by interquartile. So the answer will be 30.2. So the outlier is 2.9. from that, we can conclude that the graph is negatively skewed, or we can say that left skewed.